All right, thank you. So I tend to talk fast. If you guys see me talking fast, if we just do this, I'll talk a little slower. But I did rehearse it a couple times, so hopefully it goes well. All right, we're going to start off with a little bit of audience participation. So how many of you have ever heard of Docker? All right, how many of you have heard of Docker Compose? Okay, how many of you have used Docker Compose? Okay, so a lot of you. So I'm going to go over a super quick, brief introduction of Docker. It seems like most of you know what it is, but I'm just going to, it kind of builds up into what we're talking about today. So what is Docker? It is a daemon for controlling containers. Okay, so what is a container? A container is a running instance of an image. I feel like we're getting somewhere, we're really building up. So what's an image? An image is an ordered collection of file systems or layers. So this is things like the software, the dependencies, the libraries, configuration. Also contains stuff like metadata, so tags, which usually denote the version of the software that's running in the image. Which ports you can expose, which volumes you should probably mount. One note is that images don't change. If you need to change a file, update a file, change a configuration, you just create a whole new image. So what is Docker Compose? Docker Compose is a tool for managing multiple containers that should be run together. This simplifies the use of Docker, so you don't have to run a bunch of commands to get an environment spun up. You just kind of make one configuration file, spins up the whole environment for you. The configuration file is done in YAML. This contains things like services, networking, volumes, all are within this configuration file. So why would you use Docker Compose? So Docker Compose helps with, it's a reproducible config. You just type it out once and you can just use it over and over again. You can also add it to things like it's distributable. So you can add to things like Git repository, version control, and distribute that so that people can run the same environment you do. It's also cross-platform. So it runs on top of Docker, or is part of Docker at this point. So it runs on Linux, Mac, Windows. So let's jump into a demo. Does that size look good for everybody? All right, cool. So this is a Docker Compose file. At the bottom of the screen, you can see the file's name is docker-compose.yml. So it's a YAML file. Typically, this lives in the root of your project. And whenever you run a command, this is the file that it'll look for. This is configuration for Docker Compose. So you can have different Docker Compose files for different projects. So you can see there's one top-level element, and that's services. Inside of that, we have two. We have app, and we have DB. And then inside of each of those services, we have configuration for those services. So the first one, we're listing an image here. This is an image would probably typically come off of something like Docker Hub. So I'm using a PHP image and version 8.3-CLI. So we're going to be running a PHP project today. The next line specifies the command that runs when the container starts up. So I'm running PHP artisan serve, and for those of you who know, that's a Laravel project, so we're going to be running a Laravel project from on top of PHP. Next we have ports. So ports is a list. You can expose multiple ports, just one port. But I'm mapping port 80 on my host machine to 8,000 inside the container. So Laravel by default, when you run PHP artisan serve, runs a Laravel development server, that runs on port 8,000. So I'm going to map that to 80 on my host machine so that I can view that in a browser. Next we have the working directory. That's just the directory that will be put in when the app starts up. So it'll make a little bit more sense when I talk about the next one. So volumes, we're going to map the current directory that we're in when we run these commands. We're going to map that to app inside the container. So we map it to app inside the container starts in the app directory, so everything's just kind of there. Then when we run the PHP artisan serve, all those files are there and accessible to us. The next one's mostly for convenience. We just don't have to wait for any timeouts when we run Docker Compose up, Docker Compose down, that just kind of kills the container instead of waiting for a timeout. Typically, you don't need that in your Docker Compose, but when you get the demo, it makes it quicker. All right, so under the database service, we have another image. So this is MariaDB, similar to MySQL, if anybody's ever used that. And the next part is environment variables. So if you read through the documentation for your database containers, which I highly recommend if you always read the documentation. But if you have these environment variables set up for the MariaDB database specifically, also MySQL, it'll initialize the database for you, create a user for you, do all this fun stuff. So always make sure you read the documentation so you find out cool tips and tricks like this. So now we have our configuration file, but how do we start this service? So I'm going to head over to my terminal. The command to start these services is docker compose up. And I'm not going to be able to type because people are watching me. When I did this in the demo, nobody's watching. I can type fine, but I'm not going to be able to type today, so just bear with me. So we're going to run docker compose up. When I hit enter, you can see it's creating a network. It created a couple of containers. It's starting to spit out some logs. In a second here, it'll spit out a lot more logs. Oh, I'm so slow. There we go. So we can see this is actually initializing the database that I was talking about. It's creating the user, creating the database, and then it restarts the server one so that all the user in the database is already there. So now let's check out our browser. So we can just head over to localhost, and you see it runs something. We're getting an error, but it's running something. So that's cool. So the error we're getting is no such tables session. So it can't find tables. If you're familiar with web development, typically the way that you make tables in a database is something called a migration. So Laravel offers a command you can run to run migration, so let's go and try that. If we head back to our terminal though, we see it's blocked. It's, we don't have our prompt back. So let's, push Control-C, see if we can get our prompt back. So we do get our prompt back, but it says to stop the containers. It's not what we want to do. We want to keep those containers running. So we kind of want to run it in something called attached mode. So if we run docker compose up-d, that will run the containers in detached mode. So I can hit enter, it sees it started the containers, and then we get our prompt back. So, but if we wanted to check if they're actually still running, how would we do that? We can run something like, actually let me move this to the top of the screen, docker compose ps. So docker compose ps shows us all the processes that are running in our current compose project. You can see the top one there to do app. That's running an image of PHP 8.3-CLI, and the service name is app. We also have a database running MariaDB, and the service name is DB. So we saw all those logs before, but those also aren't here. But we still have access to those. We can run docker compose logs, and we just get a list of all the logs up until now. We can also run, or we can also specify a service name. If we just want logs for one service, we can do docker compose logs and then the name of the service, so in this case app. And you can see we have the app logs there. If we want to follow along like we were before, we can use -f, and then you'll see that we're blocked and it's waiting to output more logs. So if I head back to my browser, refresh a couple more times, it's still going to show the error page. But at least now we can come back, and these 3 lines at the bottom are set when I refresh. So we have an ongoing set of logs if you're trying to do something like debug why something keeps failing. So I'm going to press Control-C to stop that process. Okay, so it said that we needed to run migrations. So we've run a couple of commands. We haven't run any commands inside of the container. How do we actually run the migrations? So the way that you run a command inside of a container is docker compose exec, and then the name of the service, so app. And then after that, you just put the command you want to run. So for Laravel, that would be php artisan migrate. Totally won't be able to type. Migrate fresh --seed. And if I hit enter, you'll see it's running all those migrations. So we head back to the browser and refresh that, and there we go. Now we have our app running. This is running PHP. It's also running a MariaDB database. So speaking of that, we have other commands that we can run. So you don't have to just run commands that are specific to the container. We can also do something like docker compose exec, run inside the app service. We can run bash. So now you can see my prompt has changed. Now I'm inside that container, inside that service. So I can do kind of whatever I want. So like ls, I see all my files. I can do ls etc to list out the etc directory. And you can see this is a totally separate file system. All of this is within the container. So these aren't files that are on my computer. So if I want to make a change there, or a configuration change for a specific version of PHP, I can do that. I don't have to make a change on my local system, and then I switch between different versions of PHP back and forth. I can just use containers, use docker compose. It's very easy to switch back and forth. But we have 2 services. We also have a DB service. So let's see if we can run a command against that. So I'm going to run against the DB service. And we're running MariaDB, so there's a MariaDB command. And I'm going to specify that I want to enter my password, and I want to connect to the to-do database. So I'm typing my password, and you can see we get a MariaDB prompt. If you're familiar with MySQL, this is very similar. So from here we could run things like queries. So I can do show tables. That's a little bit confusing. So I thought we ran our migration. Shouldn't they be in here? Well, we'll get to that in 1 second. Actually, we'll get to that now. So if we head back to our editor, so in Laravel by default, if I open up the .env file, so this is the environment variables file for Laravel, it loads this in, and if you set specific environment variables, it'll configure different things. So you can see here the DB configuration is for SQLite. By default, Laravel uses SQLite, which is a file-based database. We don't want to do that. Oh, wrong button. So I'm going to uncomment these next 6 lines. I'm going to write this file out. And you can see here, now the connection type is MariaDB, which is just a driver similar to MySQL that it's going to use. So now that I changed that configuration, I can head back to my browser and refresh. And you see, could not find driver. So this is a different error than we were getting before. So now we're actually using the MariaDB database, the database we're running in the container, but we're getting could not find driver. This is very typical when you're using Docker or Docker Compose. The upstream images do most of what you need, but not everything. So we obviously need to add a driver here, and Docker Compose makes that super simple. So we head back to our editor and open up the Docker Compose file. We can change this line here to build : period. I'm going to write that out. And so what this tells Docker Compose is, look in the current directory for a Docker file and build that for me, and that's what I want to use as for this app specifically. So if we open up that Docker file, you can see we're using the image PHP 8.3-CLI, and that's the one we were using before. But we add this one extra line in here. And this adds the MySQL driver, which is also works from MariaDB, as a PHP extension. So we just have to add that one line to add this driver. But this is a Docker file. Again, this also kind of lives in the root of your file, or the root of your project. But it can live somewhere else if you want to specify a different path for the build. But since we made a change to this docker compose.yaml file, what we need to do is run docker compose up again. We need to tell docker compose, we made a change. Can you validate what state you're in and get into the correct state? So I'm going to run docker compose up-d, and if you see it says 1.1 seconds over there, it might be a little bit dark, but it says 1.1 seconds, so it recreated the app container. So it built the app container and then spun that up for us. And we can see that if we run docker compose ps again, you'll see the top one before underneath the image next to the to-do app used to say PHP 8.3-CLI, but now it says to-do app. That's a custom image that Docker Compose has built for us and is now run. So if we head back to the browser and refresh, you can see now it's giving us the error it did before, table sessions not found. So we just need to run that in migration command again. So again, when you want to run a command inside of running service, docker compose, exec, then the name of the service, and then after that, the command that you want to run. So I'm going to run the seeds again, and then when we head back, we're in a good state again. So there's one thing that I sort of skimmed over when I was in the editor when I was going through the environment variable file. So this is, again, the Laravel configuration file. And you'll notice that the connection is MariaDB, that tells you what driver to use. But the host is just DB. So inside of Docker Compose, it creates a network for you, and then runs all of your services inside of that network. So typically when you have configuration, you want to connect to an external database or something else, you would have to specify an IP address or some DNS name. In Docker Compose, you can just use the name of the service. And since they're in the same network, Docker actually wires it up so that you can just specify the name of the service and it knows how to talk to the other service. So I believe it uses DNS to achieve this, but we can just use DB, which is the name of the service that we want to connect to for our database. We also use 3306 as the port. But if we head back to the Docker Compose file, you'll see that I didn't export any port for this database. Well, again, since they're on the same Docker Compose network, they can talk to each other on ports, even if my host machine can't access those ports. So the app service can talk to the DB service on that port, even though it's not accessible to my local machine. But let's say we do want to access it from our local machine. Let's say we want to use like a GUI database client or something to view it. We might copy these 2 lines here. We just add to this service down here. And I want to change this to 3306. And we're going to change this one to 3306 as well. So I'm mapping port 3306 on my host machine to 3306 inside this DB service. So since I made a change to the Docker Compose file, remember, every time you make a change to the Docker Compose file, you have to run Docker Compose up again. So I'm going to run Docker Compose up. You see it's recreating the database service. And so now that port is exposed. So if I head, if I head over to my local editor, or local GUI for database stuff, you can see I have a database named Docker Compose, connecting on localhost, port 3306, the username to do, I got the password, and the database is to do. So now if I hit connect, now I can actually connect to that database. And tasks is the table that we care about. You can see there's a couple of tasks listed there. Okay, so we have our app running, there's data in it, some of the data we care about, so like new thing. But But let's say we work on multiple apps, multiple projects, we have other Docker Compose projects, and during the week we shut down our laptops, we're going to simulate that with Docker Compose stop, and then we do other stuff, we're building a bunch of images, and our disk is complaining, our disk is getting full, which is typical when you're using Docker, especially if you work on a ton of projects. Docker takes up a ton of space. So a typical command you would use to clear up some of the Docker space would be Docker system prune. So we run Docker system prune, you see it says, warning, this will remove stop containers, networks, dangling images, a bunch of build cache. Okay, we don't care, we just need some disk space back. I'm trying to compile something or whatever, so we're just gonna hit yes and go. And this is a non-typical scenario, I just ran this demo, so 0 bytes are being cleaned up. But when I ran it last night, I cleaned up 4.5 gigs. So not an unreasonable, or not a small amount of space, but yeah, cleaned up space. But we weren't thinking about all the projects we were running or all the containers we had running before, so then we're tasked with coming back to this project, and they say, whenever you check a box, send an email or something. So we come back to this project, we're in this project directory, we Docker Compose up, -D, and we go back to our browser and we refresh, and we're getting this connection refused. But if we refresh, after the database is reinitialized, eventually, there we go. Okay, now we're getting the same error. The sessions table doesn't exist. Well, we already dealt with this. We already ran the migrations. Why is it gone? So if you don't specify volumes for Docker services, it uses an anonymous volume. And since it's an anonymous volume, Docker says, this is just temporary data. So whenever you run Docker system prune or other cleanup commands, it's just going to delete that. It assumes it's data you don't care about. So how would we fix that? If we had this project, we had data in this project that we wanted to keep, how would we fix that? So I actually have a command here, so you don't have to watch me type this out. So I have these 4 lines at the bottom of the file. And let's start with this one. So there's this top level element called volumes. And then inside of that we have one named volume. So we're going to name this volume database. So then under the DB service, we also added a volumes attribute. And we're mapping the named volume of database to var lib MySQL inside the container. So if you're familiar with MySQL and MariaDB, this is where all the database files are stored, kind of the stuff that you need to bring the database back up with the same data. So we've now named that volume, and I'm going to write that out. Since we've made a change to our Docker Compose file, you have to run Docker Compose up again. So we'll run Docker Compose up -D, and you'll see at the top there, it said, or I guess not at the top, but underneath the prompt that I was on, volume, to do database created. So it created a new volume. And as you can guess, since we created a new volume, we mapped that into the container, that volume is empty by default. So we're going to get the exact same error here, table doesn't exist. So if we run the seed command, or the migrate and seed command again, now we have all our data back. All that data was put inside that named volume, and so Docker will save it for us. So I'm going to do this as a new task. And then let's simulate that flow again. Kind of you're working on other projects, you're doing other stuff. So I'm going to run Docker Compose stop to stop this project. I'm going to run system prune to prune all the extra stuff. And we'll be surprised when it shows there's 80 gigs of stuff that it deleted because we're working on all different Docker containers and building all that extra stuff. And now our disk is clean again. We feel good. But we come back here, we run Docker Compose up -D, and we refresh, and our data is still there. So since we've named it, we've told Docker Compose this is an important volume. The stuff in here I want to keep. Don't delete it unless I explicitly tell you to. So that's good if you have a project, you have a lot of custom data, that you just want to keep around, stuff that's something that's hard to reproduce that maybe might not fit in seeds very well. Okay, so next thing. So we talked about that, the command we talked about whenever we check one of those boxes, the thing we've been tasked with is sending an email. So I'm going to open up a new file that I created. So I created a new file in the root of the project called dockercompose.override.yml. And you'll notice that this looks a lot like the Docker Compose file. Because it is very similar to the Docker Compose file. So at the top level we have services. We label one service under here. We give it an image and ports. We've done all that before, we know what all that stuff is. But the thing that's special about this file is, typically this file isn't tracked by Git or stored in version history. The Docker Compose file is with the project, so that is stored with your version history. So this can be your own file to run your own services in that maybe don't belong in the project, but you want it as kind of like a additional thing that you don't want to plug up everybody else's stuff with this. So these two files are merged together, and then Docker Compose starts all the services in all of these files. So if you want to expose one extra volume or add a whole other service like we're doing here, you can do docker compose.override.yaml, and that'll allow you to do that without actually committing anything upstream or doing any of that. So again, these are merged together and then start all the services. So since we technically changed the docker compose file, we need to run docker compose up again. So when we run that this time, we see it creates the mailpit service. Just realized I didn't explain what the mailpit service is. So mailpit is essentially an email catcher. Any emails that you send to it, it'll just accept and kind of show you in an inbox. So look at what that interface looks like. So it looks very typical, or very similar to like an email inbox, and it'll catch any emails we send to it. So the next thing we probably want to do is update the configuration to actually send those emails there. So this is the Laravel configuration file again. You can see currently it's sending it to logs. We don't really care about that. We want to send it to SMTP. You'll notice again, the host name is just the name of that service. We don't need to know the IP address. We don't need to make any DNS entries. We don't need to care. We just have mailpit is the name of the service, send all the email there. And since they all run inside the same Docker Compose network, they know where to find each other. So head back to the browser. And actually, let me just administrate the email code, so I'm going to show you that quick. So inside the update method of the task controller, I just have something, send a mail to amair@example.com and send them this email. So back here, if we actually do an update, so something like checking this box here, we say check now, and we see we get a little icon at the top, says we have one email. We go there and we check, it's to amair@example.com, and this is just a text email, so it says task, this is a new task, status complete. So every time we check it, it sends it here, we can verify the email, and we're good to go. If you have HTML emails, they'll render a lot nicer. For this demo, I just did a text email. So final thing we have is, let's say this was an open source project we were working on, or a project that's temporary work, not something we're going to have to work on all the time, and we just want to clean up all this space. Again, I said Docker takes up a lot of space, especially if you're working on a lot of projects, building a lot of images. So how do we clean up this whole project? We just kind of want to delete everything. So the command for that would be docker compose down. And if we run that, we can see it stopped all the containers, it removed them, it also removed the network. The one thing you'll notice it didn't remove was that volume. So I said, when we name that volume database, it'll keep that database until you explicitly tell it to delete. So the way that we tell it to, we want to delete volumes as well as with the -v. So docker compose down -v, and you'll see there it removes the volume. And that's all I got. Does anybody have any questions? All right, I think I explained it perfectly. Oh, one question.
Have you worked with Docker Compose profiles before? I recently came across them and I didn't really know it existed.
I have never heard of Docker Compose profile, so no, I have not.
No worries.
How do some of the Docker Compose features like interact with the standard Docker file stuff? So you can specify volume in the Docker file, right?
Yeah.
So does that MariaDB image have volumes configured at the Docker file level? And why would, how do you choose where to put those kind of?
Sure thing. So when you specify volumes in a Docker file, so if MariaDB has a volume listed in its Docker file, that's mostly a hint to the system. It doesn't actually create that volume for you. It's a hint that says this is a volume you probably should mount. Same thing with ports. If you expose port, 8,000, it doesn't actually expose that port when you run it. You have to actually specify to expose it. That's mostly metadata to tell you, hey, this is probably the ports you should mount or expose, and these are probably the volumes you should mount. So in Docker Compose, you would need to put them in Docker Compose to say explicitly, these are the volumes I actually want to mount. But the volume lives in the same volume directory as Docker, and the networks live in the same networks. If you run Docker volume list, it'll show the volume as well.
Thanks.
So let's say you're going to deploy this across a couple hundred servers, or even just, let's say you say 3. What's your rule of thumb for just having the Docker, building each one of those on each individual machine as compared to taking the Docker Compose, building a brand new image, and then actually just pulling that image down and just pulling a pre-built image?
Okay. That's a great question. A little bit outside the scope of this talk, because this was just for local development. You can use Docker Compose on servers, obviously. Typically, so if I was going to do that setup, so this was mostly for local development, but if you were going to use Docker Compose on a production server, I would say you want to build the images once and deploy the same image to every server, because then you have the repeatability. It wasn't the one server built or had an older version of the image pulled, maybe it was Maria DB10 instead of Maria DB11, and now there's some difference, and I have to debug production. So I would say if you're doing Docker Compose in production, I would recommend building the images, pushing it up to Docker Hub, and then pulling that image on every server.
What do you think is the best way to access like secrets that you don't want to commit in your Docker Compose file? I saw you had some syntax in there.
That is a great question. So in Laravel, that kind of depends on the framework you're using. So in Laravel, we have this .env file, and so that's not committed to Git, that's not part of the Docker file. And this is where all the secrets would live. So I don't know if you noticed under the database, like the database password is listed in plain text here. But that's where I would put secrets. I would keep them in configuration files that are not committed to Git, not in Docker Compose. The way that I got those into the Docker Compose file is this is the syntax for if you want an environment variable, and then if you have this colon and a dash, this is the default. So, but if you always had the configuration file and you had this would read the DB user from that env file and then just put it for that value. I put the default because Laravel by default uses SQL, so the first run through with this variable didn't actually exist. Any other questions?
Are there dependencies between the containers that you have running there? So if like your DB doesn't come online for some reason, is the entire Docker Compose command breaking, or is it really like PHP still running, DB is just in a broken state?
That is a great question. So there was a little bit too much added into this talk, but there are dependencies. I think it depends on, you can read the documentation. So it depends on, you can add here, and then, if I didn't spell that right, I don't know, yeah. But then you can do DB, you can list the service, and then one thing that is weird with that is, so it will start the DB first, but it doesn't actually have any way of monitoring that process. How does it know when it's running? So there's also health checks you can add. If you add health checks and depends on, it will spin up the database, wait until the database is healthy, and then bring the app online. But I would recommend reading the documentation for that, because I don't know all the syntax off the top of my head. All right, no.
So for local development, so as you're spinning up your containers, how much extra provisioning, like memory-wise, do you really need to have on your machine to do this effectively?
That depends on your operating system and on what type of containers you're running. So the PHP and MariaDB are very small. I'm also running on a Linux machine, so I have a slight advantage because these run right on the host operating system. If you're on a Mac or Windows, depending on how you configure on Windows, it'll run inside of a virtual machine, and that virtual machine has a static amount of memory. So on Mac, you can provision, I think by default, something like 4 gigs of RAM and 1 CPU, but you can adjust that up or down as you want to go. Same thing on Windows. Windows also has the Windows subsystem for Linux. If you run it there, you kind of get the native experience, so there's not very much overhead, but that's very dependent on the image you're running. So PHP is very, very, very lightweight. MariaDB is also pretty lightweight, so I would say, these on my machine are probably using half a gig of RAM and like 1 or 2 CPUs. Does that answer your question? Perfect. All right, I'll see any more hands. Thank you guys very much. Oh, one more hand.
Yeah, it's kind of a basic question, but what is the difference between a virtual machine and a container?
That is a great question. I had a slide about that and I took it out because I thought it was would take up too much time. So the difference between a virtual machine and a container. So Docker, as we mentioned, is a daemon that runs on your system. And so that's just another service or program that runs on your system. And then it will spin up the container. So since I'm on Linux, I have a daemon that's running called the Docker daemon. And then it will actually just start the containers on my system. They run as just more processes on my system. With a virtual machine, you have a whole guest operating system. And a virtual machine also has to have a virtual CPU, it has to have virtual RAM, it has to have actual file on the disk to store the whole entire file system. So you have all the extra overhead of, if you were running 4 virtual machines and each of them had 1 CPU, that's just 4 CPU cores that you can't use on your host operating system. Also, they use a static amount of RAM, so you have to allocate RAM to them and disk space. So you're running your host operating system, then inside the virtual machine you're running a guest operating system, and then you're running Docker on top of that. So that's the difference between virtual machines and Docker.
Just a recommendation from you. If you're building a new project, are you setting it all up with Docker first, or are you going and messing with it locally without Docker involved and then backfilling it with Docker, to make it work with Docker?
That is a great question. So when I start on a project, it kind of depends on if it's a greenfield project or if it's an open source project I'm downloading online. So if it's a greenfield project, I'm going to start with Docker Compose right away because I just want to run my server. And for the record, I do a lot of web development, so this Docker Compose suits web development very well. If you're doing something like a compiled, like C++ or Go, Docker Compose isn't going to serve you quite as well. Docker would be a better fit there, I think. But if you're doing web development or anything that needs services to be running, I would say I start with a Docker Compose file. But I also download, or I also work on a lot of open source, and those won't have Docker Compose. I can just add a Docker Compose file and don't commit it. Just use it for myself locally. But yeah, Greenfield, I would start with it fresh and then use Docker Compose. Open source, if I need to backfill, I will. Or if I start an organization or start on a new project with the organization I'm at and they don't have Docker Compose, I'll add it in there just for myself and then reach out to whoever's in charge of the project and be like, hey, I did this thing. Are you guys interested in that? Should I commit it? So yeah.
Well, actually, you can go there.
Was there one question over here? Yeah.
Yeah, that's taking Docker Compose to sign up for deployment.
So that kind of relates to his question. So this was just for local development. I currently don't use Docker Compose for doing deploys. There's other better products that fit things like that. You can use it for Docker or for deployments. So you would want to build out your own Docker file to make sure that you have the exact dependencies you want. But yeah, you can use Docker Compose. You can run Docker on a server and do Docker Compose up, and that is a pretty good way of doing deploys and do Docker pull. Yeah.
Does this translate Kubernetes?
This, so I actually was talking about somebody with Kubernetes right before this. So this is a very good step. If you want to learn how kind of Kubernetes works, this is a very similar flow to how Kubernetes works. This file doesn't translate directly into Kubernetes, but all the Kubernetes manifest files are in YAML. So if you're familiar with specifying things like the command that it runs and what is your working directory, things like that translate very well over to Kubernetes. But this file specifically, you can't just plug this into Kubernetes and it runs. All right, I think we're good. Thank you guys very much for your time.